Welcome to my third video on I2C on any PC. In this series of videos I show you how to access the I2C bus from a standard PC or laptop. And I've already shown you how to access the I2C bus if you have a free PCI Express slot or if you have a free display connector like VGA. But today I will show you a more convenient but a little bit more expensive solution. So almost every PC has a free USB port. So why not use a chip which translates USB into I2C? And luckily there are some chips on the market, and today I will present two of them to you. So the first one I want to show you is the MCP2221A from Microchip. A cool thing about this chip is you can get it in a dual inline package. And this is really cool if you want to prototype on a breadboard or if you want to build your own PCB, because this package is really easy to solder. This chip is a USB to I2C and UART bridge, and it also offers 4 GPIO pins. You can get this chip for about €3, and if you want to have it on a board you have to pay about 7 to 15 euros. So of course this is much more expensive than a simple VGA cable which you cut into half and connect your I2C from there, but yeah, therefore you have a separate chip and all you need is a free USB port. But this chip has one big downside. So if you connect it to your Linux PC, all you will see is a new UART port appearing in your device files. If you want to access the I2C bus or the GPIO pins, you have to access the HID, or you have to use the USB HID interface. You can use HID RAW for this, or you can use libUSB for this, but this is not so convenient. There are some drivers for this, but they are not pre-built in, or they are not shipped in the standard Linux kernel, so it's a little bit of pain to get them up and running. And this is where this chip here shines. This is the CP2112 chip from Silicon Labs. This is a USB to I2C bridge with up to 8 digital GPIO pins. And the big advantage of this chip here is all the drivers are part of the mainline Linux kernel. So if you plug this chip over USB into your PC running a GNU/Linux operating system, you will get a new I2C connection and a new GPIO chip appearing in the device files. The disadvantage of this chip is it's only available in this package, and this isn't solderable by hand any longer. But hey, you can buy a small PCB with this chip assembled on it for about 10 to 50 euros, which is again more expensive than a VGA cable, but therefore you will get this cool PCB here. So the chip you can see here in the middle is the CP2112. I have a micro USB connector, and here I have some pin headers to connect the power supply, the I2C bus, and 4 of the 8 available GPIOs to a breadboard. And in today's video I will use this simple I2C I/O expander, and I want to control the onboard LED of this chip over the GPIOs, and I want to access this I/O expander to control the LED and the button here. So now let's give me a second while I'm doing the wiring, and then I'm back. Okay, so I have connected the two boards, but before now I plug this into over USB to my PC. I have to load the Linux driver for I2C accesses from user space. So what I will do here is I will load the module I2C-dev with modprop, and of course I have to give it my password. Okay, and now if I search for I2C devices here in my dev folder and for GPIO chips, I can see here I have one GPIO chip and I already have 9 I2C buses on my PC. So these buses came from the display connectors and from the SM bus, and this also comes from my main CPU. And now let me connect the board over USB, and let's rerun the command here. And now you can see I have 2 GPIO chips and I have a new I2C device here, number 10. And now if I run GPIO detect, so number 0 is from my CPU, number 1 is the CP2112 GPIO device, which I've connected here. Okay, so now I will use GPIO set to set pin number. So from GPIO chip 1, I want to set pin 0 to 0 because one of the onboard LEDs is connected to this port. And if I run this, you can see here, yeah, an LED is up and running. And if I write a 1 to it, the LED is off again. Okay, and now let's try the I2C access. So I will run I2C detect first, and I will detect, and I will list all the available I2C buses. So here we have some buses from my graphics card. Here we have some from the SM bus, and this last one here, number 10, is the CP2112. And now let me run I2C detect, and let's use this bus here. Oh, I need just the bus number. But one sad thing is this I2C adapter doesn't support SM bus quick write command, so I2C detect doesn't work. But if I use I2C get to read from the device, and I know the address of this I2C device is 32, I will get back a 2, and this means the button is not pressed. If I press the button now and rerun the command, I will get a 0. And if I release the button again, I will get the 2 again, because I've connected the button to pin 2 here. And to light up the LED, I have to write a 0 to port to pin 0. And I can do this with I2C set, bus number 10, address 32. And let's write out 2 zeros. Yeah, it's a little bit hard to see, but this LED is on now. And if I write a 1 out here, yeah, the LED is now off. Yeah, it's a little bit hard to see, but you have to believe me. Okay, cool. So this is a very convenient way to access the I2C bus from any PC. Because let's be honest, almost every PC has a free USB connector. It's a little bit more expensive than using a VGA cable, for example, but it's more convenient because you don't have to cut off a cable and search for the right pins, so this is really convenient. So I guess that's it for today. I hope you've enjoyed the video and learned something. If you want to support my work, you can buy me a coffee on buymeacoffee.com/JohannesForLinux. So that's it for today. Thanks for watching and goodbye.